Challenging the Stigma of Formal Program Repair, position paper by Batchen Rottenberg.
Hello everybody, my name is Batchen Rottenberg and my research area is formal program repair. In formal program repair, the program is repaired with respect to a formal specification and is required to meet it for all inputs. This is in contrast to test-based repair, where the program is only required to pass a certain set of tests. When I attend a conference and tell other people about my research, people often raise an eyebrow when I tell them I do formal program repair. The usual concerns people have is that formal algorithms are not applicable to real-world programs and that their efficiency is very limited. In this talk, I will present some of the most frequent questions I'm asked and use them to try and break the stigma of formal program repair. So the first question I'm asked regards applicability. Isn't it true that most programs don't have formal specifications? Doesn't that make formal repair irrelevant to most programs you find in practice? Well, to answer this question, let us consider the simple program for calculating the average of an array of integers. This program is not likely to be accompanied in practice with a formal specification describing its input-output relation as a logical formula. However, it does have an assertion that describes some desired property. In fact, for most modern formal repair tools, this assertion is sufficient. The specification used will be that the assertion should hold for all possible inputs. As a matter of fact, even if this assertion would not be present, formal repair could still be applied to ensure safety properties such as the lack of array out-of-bound access and null dereference. It could also be used to prevent errors related to division by zero and integer overflow. So in fact, formal repair is applicable to almost any program you can think of.
The next question regards efficiency. Isn't formal verification very inefficient in comparison to testing? So doesn't that make formal repair very inefficient in comparison to test-based repair? Well, no one really knows. No studies have been made so far to answer this question thoroughly and properly. In addition, comparing the performance of test-based and formal repair algorithms requires a benchmark of programs equipped with both the test suite and the formal specification. None of the existing benchmarks for program repair is adequate for this purpose. To make matters worse, trying to artificially create such a benchmark by adding tests or formal specifications to existing programs may create an unfair advantage to one side or the other. Despite all of this, one study, and to the best of my knowledge, only one, did compare formal and test-based repair algorithms. The study was conducted by Nguyen et al. In 2019. It used two test-based tools, Ngelix and GenProc, and three formal tools, All Repair, Forensic, and their own tool called Maple. Experiments were conducted on the TICAS benchmark, which implements a traffic collision avoidance system for aircraft. The benchmark consists of 41 faulty versions of approximately 140 lines of code each. The specifications used for the experiment were 50 test cases per version for the test-based tools, equivalence with a correct version for All Repair and Forensic, and a manually written specification for Maple. All specifications were taken from previous experiments done by each of these tools on this benchmark before. The results of this experiment are summarized in the following table. The table shows the average time it took for each tool to find repairs for all versions in which a repair was found. For convenience, formal tools are highlighted in blue. What we can see in this table is that the fastest tool to find repairs, surprisingly, is All Repair, which is a formal-based tool. The next in line is Maple with 155 seconds, which is also a formal-based tool. The third tool is a test-based tool, GenProc. If we consider only versions where a correct repair was found, the results are even more conclusive. Here, GenProc becomes irrelevant because it was unable to find a correct repair for none of the 41 versions. The remaining test-based tool, Ngelix, is now significantly slower than all three formal tools. Now, obviously, we cannot draw any broad conclusions from this small experiment. However, these surprising results prove that formal repair can obtain correct repairs efficiently for some programs. This highlights the need to conduct further research to check its ability on other programs as well.
The next question regards repair quality. Test-based repairs often suffer from overfitting to the inputs in the test suite. In contrast, formal repair guarantees correctness for all inputs by construction. So, are formal-based repairs better? Are they more likely to be accepted by developers? Well, the short answer is no. The longer answer is that it depends on the specification. The more you're willing to invest in converting your intentions to formal properties, the more you're likely to be pleased with the repairs you'll get. But if you recall, the specifications we currently find in practice are usually partial and describe only some desired functionality. Therefore, you may want to ask, for programs and specifications we do find in practice, what percentage of formal repairs produced are spurious? How does this number compare to test-based rates? How will it change as a function of the specification quality? And how do you even measure specification quality when the specification is a formal one? All of these are valid questions and very important ones. However, unfortunately, as you may have guessed, the answers to these questions remains unknown. While there are some anecdotal studies on the quality of formal repairs, such as the study by Nguyen et al. Presented before, a large-scale, comprehensive experimental evaluation of this topic has yet to be made. I can, however, give you my 2 cents on the comparison of test-based and formal repairs in terms of quality. So, to give you my intuition, imagine that the correct input-output function for the repair we are looking for is this function f from x to y. A test suite is likely to give us information on the value of f at some specific points. For example, that f of -6 equals -2, or some other points. A formal specification is likely to give us global information about f, such as its image should always be contained between -4 and 4. So these 2 types of specifications both give us partial information about f, which leads to spurious repairs. However, each specification provides some knowledge about f that the other doesn't have. This leads me to believe that formal and test-based repairs are orthogonal in terms of quality. And the next conclusion is that we should probably combine them, because repairs that are found plausible using both specifications are more likely to be correct in practice. To sum up, according to the Stigma, formal program repair is less efficient and more correct than test-based repair. However, this is only a stigma. It is based only on what people believe, rather than on what has actually been tested and proved. I hope that in this short presentation, I was able to get you to keep an open mind when it comes to formal program repair. I would like to end with a call to all of you to do more research on formal program repair. Together, we can make formal repair better. We can answer the many remaining open questions, and we can combine test-based and formal repair to get the best of both. Thank you.
Okay, now we are online. So if anyone has any questions about formal program repair, please ask and write it in the chat. Well, actually, while we are waiting for the questions, I also have a quick question. So in your presentation, you discussed like the importance of formal program repair and the advantages. So I have maybe a little bit more general question. Is because for me, like in software engineering, in the kind of research we are doing, the important part is to reduce complexity, like in a general sense, like reduce complexity of development, software development. So do you see that formal program repair addresses this problem better than informal program repair?
Do you mean, does it make programming easier more than...
Yeah, so do you expect that it will be easier to create software by using formal methods for creating and for repairing compared to other methods that don't use formal methods?
I'm not sure. I don't think this is a particular advantage for formal program repair. Because as I mentioned at the end of the presentation, it may seem like formal program repair provides somewhat better repairs, or they are, I don't know, more correct, but this isn't really the case in practice many times. So I'm not sure it's better than test-based repair in that sense.
Yeah, okay. So maybe I will just clarify, because, like, for example, there is some trade-off. For example, if you write tests, it's easy to write tests, but you never get any guarantees. So in the end, it might be wasted effort sometimes. When you do formal methods, it's harder to write formal methods, but in the end you have some guarantees, and eventually it may actually simplify the development. So that's why what I was asking you is about this in a more general sense, not just whether easier to write tests or not, or write formulas, because obviously writing tests is easier, but whether it's easier to actually develop software this way in principle.
Yeah, so if you look at the whole debugging process as a whole, where you have to find the bugs and then repair them, then if you do test-based repairs, of course, you'll have to write the tests. But if you do formal program repair, sometimes it can even be easier because you can not write anything at all and just use built-in assertions or built-in memory safety properties like we saw in the previous work presented here. So in this sense, yeah, it could be easier, but in terms of, the ratio between your profit and your effort, I'm not sure if this ratio will be better if you use formal program repair, because you may find that you're investing a lot of effort in writing formal specifications, and still, even though you get some guarantees, which of course is an advantage and it's very important in some domains, sometimes these guarantees sort of don't help you. You have the guarantee that, okay, there won't be a memory violation here. But what about the rest of the code? Or what about some other properties? So maybe you don't have a memory violation now, but you lost some other desired property. But then again, you have the same problem with tests. So the question of which will be more, where is this ratio will be more, where would it be easier in the end? I don't know. I really can't say. It's sort of incomparable in a way.
Mm-hmm.
I think this is a more general issue, that the comparison of test-based and formal repair methods is really sort of apples to oranges. I find that you really can't make a fair comparison of almost anything, not of how the repairs look or how well is the specification, how hard was it to get the specification. All of these parameters are sort of incomparable. You need
Yeah, sorry, I actually have only 3 seconds, but there is a question from Shinclay.